All right. Well, good morning again, everyone. Welcome to this session on defining requirements-based packet capture strategy. My name is John Pittle. I do work for Riverbed Technologies. I'm a global architect in the performance management services practice. And my role is to help customers adopt our various technologies around performance management and how to craft the different solutions together and integrate those into the processes and workflows around service management. So let me give you a little premise about why I wanted to create this session. First off, we love packets. If we didn't love packets, I don't think we'd be at a Wireshark SharkFest conference. Is that a pretty fair statement? Everybody here really is intrigued with doing packet analysis?
Yes.
Yeah? Okay. And there's a lot of performance and availability issues that can only be solved when you have the packets. I mean, I think during some of the sessions this week, you've seen some great field case studies where if you didn't have the packets, you'd never get down to the details of why there was an issue, whether it was slow application performance, congested networks, bad wireless, bad security, things like that. But there's a problem. The problem is we often don't have the packets that we need to do the analysis. People will come to us after the fact and say, hey, I had a problem yesterday, can you go figure it out? And there's no symptom data to look at. There was no capture running, things like that. So we don't have the packets that we need. And the solution is to create a requirements-based design that you can share with management and explain to management what the risk is to the business because we have gaps, because we can't see what we need to see in order to solve problems when they should arise. And so we're going to look at some ideas around how we can assess those gaps and how we can document those gaps for management. So my goal is to help you, help your management help you, by getting you the funding that you need to get the visibility that you need, not just because it's the newest, latest, coolest technology, but because you're actually trying to solve business problems. Sound good so far? Yes? So I'm going to ask you guys to engage and participate. I'll be asking questions. I'll be asking for feedback. I'll be asking what do you guys see in your environments to share information with one another, learn from your peers, and we're going to learn how to improve your craft around troubleshooting and packet capture design and increase the value that you can bring to the business. So your agenda, this is me thinking if I was you out there and not me here, what would I want the agenda to be? Learn how to utilize your troubleshooting and analysis skills, because that's what you're learning this week. To identify risk to the business, and we're going to be talking about business risk throughout the presentation. When you don't have the packets that you need for the visibility and troubleshooting. Okay? I'm going to share with you some ideas around how you can identify the gaps and use a process to document a roadmap of how you can propose to management, hey, we've got these gaps. I know we can't solve them all at once, but how can we do a phased approach to address the gaps over time? So in terms of what I'm going to discuss, we're going to do a brief level set of something I call a performance management landscape. What are all the different technologies and instrumentation and tooling that make up a comprehensive performance management program? Then we're going to deep dive into packet-related workflows and technologies. We're going to look at some ideas around how you can document requirements and create a business case. What are some of the mechanics around that? Then we're going to look at some examples of gap analysis and risk heat maps, and then we'll look at some final recommendations and wrap up. So we do have quite a bit of material to go over. I can tend to wander and get off on tangents. I'm going to try my best not to do that today. But I would like to get a couple of volunteers. I need a 10:45 a.m. volunteer. If somebody could let me know when it's 10:45. Who's that? Who will that be? Anybody? Okay. Thank you, guys. So 10:45, give me a ping, please. And then I need a volunteer for 11:10.
Okay.
Thank you very much. 11:10, let me know when we're there so I make sure that we finish on time at 11:30. Appreciate that. So let's get started. The performance management landscape. It's packets, right? Yeah, I mean, we're here to talk about packets. But really, the landscape of performance management capabilities is quite a bit more. Yes, it's packets, but it's also an user experience, monitoring endpoint devices, some other technologies that we're going to explore in a little bit more detail, just to give you a context of where do packets fit within a bigger picture of performance management as a comprehensive strategy. So in order to kind of frame this discussion, I want to introduce a deployment model for most large enterprises that kind of help identify what are the different deployment options for deploying IT applications and services in the enterprise. And then we're going to overlay that with different types of instrumentation. Just to give us some context, this will take about 10 minutes. So we'll do this higher level context, and then we'll deep dive into the packet portion of the presentation. So we have a concept, a simple picture of the various different deployment architectures that you find in most large enterprises today. So it's made up of, as you would expect, end user devices and locations, and you'll notice that they're in a branch office. They may be on their laptop outside of the office or simply a mobile phone. So multiple platforms, multiple locations. Then there's SaaS applications in this model that we have to support and we have to talk to. So how many people have heard of Salesforce.com?
I am from Salesforce.
Do you have Salesforce?
No, I am working for Salesforce.
Oh, you work? Well, then you've heard of them. It's a great company. I love them. We use Salesforce. I think most every enterprise uses Salesforce in some form or another. How about Dropbox or Box.com or Workday, Office 365? All of these SaaS-based applications. So just about everybody has to deal with SaaS applications from a performance standpoint. And then you have cloud hosting and cloud services. So Amazon, Azure, VirtuStream. Can you think of some others? We have some IBM folks in the room, so there's some great cloud services from IBM. Yeah, Software, Bluemix, some others. Yeah, but there's many out there. And as we're trying to support the business and support applications, we have to be prepared to deal with all of them and at least know about them and know that our applications that we're supporting may have application tiers running either SaaS or cloud. Then we have our on-prem data center, traditional on-prem that we manage. There may be remote partners that we have to interact with that are someplace outside. You know, they may be in a cloud, but they could be in their own data center, but they're remote from us. We've got multiple kinds of network technologies. We've got MPLS. In many cases, large enterprises have multiple MPLS providers. They might have both Orange as well as Telstra, as well as AT&T, Verizon, all the big providers. And then one of the latest trends is actually using the internet for transport directly in conjunction with MPLS. So we've got traffic now that can go between all these different locations across multiple different network transports. Does anybody see anything missing in this picture? A type of deployment facility or infrastructure that you have in your environment that's not covered here?
Virtualization environment.
So virtualization, so we're going to have that up in the cloud. And most everyone has virtualization on-prem as well. right? ESX or Hyper-V. And then I think Oracle has a virtual box, virtual something. Yeah, so there's different flavors of that. But it's also a big challenge that we have to prepare for and be able to support. So how do we get performance visibility to all of these different types of deployment targets in the enterprises that we have to support? So what we're going to do is we're going to use that hybrid enterprise model and talk about different types of instrumentation just to get a context, because we're going to focus on packets in just a minute, but I also want to provide and expand the thinking a little bit about how the packets fit within that bigger picture and the bigger picture of the different types of instrumentation. So it starts with user endpoint device monitoring. So you can see agents being deployed out on top of endpoint devices, whether it's mobile, laptop, desktop, Linux, Windows, MacBooks, etc. But installing an agent so that you can get a sense of what's happening on that device and what is application performance that we can measure, the user experience. What can we get from that device, taking measurements from the device that the user is actually using? So end user experience monitoring. And then there's a type of instrumentation called JavaScript injection for browser-based end user experience monitoring. Has anybody heard of that before? JavaScript injection, yeah? So you can deploy that if you have the right agreements with your SaaS providers, like Salesforce, for example. Salesforce lets you build your own pages, and as part of building those pages, you can include that JavaScript in those pages. So you can start to take end user experience measurements, even though it's a SaaS application, you can have the browser report response time back to a collector that's gathering those statistics. Also in the cloud, Amazon, Azure, etc., and even on your own web servers on-premise. So we've got endpoint monitoring, JavaScript injection, and then internal application monitoring. So this again is agent-based, where we're looking at what's going on inside of your Java and .NET applications. What code is running the most frequently? What code is using the most CPU? What code is throwing the most exceptions? What code is called the most frequently? So we've got agent deployments for that specific type of measurement. And then the traditional SNMP based monitoring around what's the health of my network devices, what's the health of my servers, what's CPU busy, let's look at CPU busy, disk I/O, network activity, and any other type of SNMP types of MIBs. This one is fairly common, and I would expect that everybody in the room has some sort of SNMP monitoring in your environment, right? Availability, is my router up, is it down? What's the link utilization on the ports on my devices, things like that. And you can see that type of monitoring really can get deployed across the entire enterprise to give you the most visibility. It doesn't necessarily go the deepest, but you can go the broadest. And then flow-based instrumentation. So if you've heard of NetFlow, JFlow, SFlow, do you guys use that in your environments today? You have NetFlow? Got some heads saying yes. So here's where we can take the view of the devices and turn on NetFlow flow generation and send that out to a collector. And something new is in many of the cloud environments, you're also able to generate NetFlow from the cloud servers and cloud components. Or as part of having agents installed that are doing other monitoring, some vendors have the ability to generate flow from those agents as well. So now we can get some visibility into better visibility into what's happening in the cloud in terms of who's talking to who on what ports and at what rates. And then packet capture and collection. So here we've got host-based capture agents deployed on the endpoints, possibly on mobile phones. I'm not exactly sure how mature that is yet, but I can see that would be coming in the future. but certainly on MacBooks, Windows, Linux, and then through span and tap, picking up traffic off of links that you can see here. And then passive appliances that are consuming all of the packets to generate, number one, a forensic trail based on the network traffic. So you have some amount of time storage where you can get at forensic data for what's been happening, what traffic has been flowing, but also the ability to do analytics against that traffic. Network performance measurements, application performance measurements, all based on network packets. And then traffic aggregators are in this. So Gigamons, and there's many others, the names just left me. Who uses aggregators other than Gigamon? So I can be reminded of a vendor name.
VSS.
VSS, right?
Ixia.
Ixia, right? I think they merged. Did they? No, they're still separate. Okay. Anui? Anui is another name. So there's a number of players in that space that are very important to packet collection, capture and collection. And of course we've got our partners at the tap table in the corner over there, one of our sponsors, so do be sure to stop by and say hello to them as well. So packet capture and collection. And then when you put it all together, you get a picture that looks a little bit like this in terms of if you had full instrumentation of all the possible types of data that you can collect so that you have no gaps, at least from a breadth perspective. This gives you a sense for, well, what does full and complete look like from a architecture and model standpoint? So let me pause there. Any questions or comments about what we've covered so far? So what I'd like you to take away from this segment is just an idea that, okay, we're here to talk about packets, but really packets are a part of a bigger picture. And that's what we just covered in this segment. So why is visibility so important? Why is visibility so important? Has anyone participated in war rooms? We got 1, 2, 3, 4, 5, 6, 7, 8. I mean, I've been in a lot of war rooms in a lot of different companies because we come in to help with troubleshooting issues, right? Performance issues. So let's take a listen, if we were a fly in the wall, of what kinds of statements get made in the war room. Hey, users are complaining, what's going on? The app is slow again. What infrastructure does it use? Sometimes I say, okay, well, how does that flow? What infrastructure? Where do we look next? What rocks do we need to look under? So a big question is, how does traffic flow across the network? What devices are in play? Hey, my link utilization is high. Who's using my bandwidth? Who's consuming it? So that's a flow type question. Top talkers, which protocols? Is it a backup running in the middle of the day? That never happens, does it, in your environment? Right? Because there's rules against those sort of things. Don't run backups during the day, so no, it never happens. But sadly, it actually does. Server utilization is 85%. Who's generating the load? So you could solve that with a traffic view, but that may not be enough. You may also have to look inside at the application code to see which code is actually running and consuming CPU. How about this one? How long has it been going on? You ask 3 different people, you get 3 different answers. Oh, it started last Tuesday. Oh, no, for me it started yesterday. Oh, for me it started last Thursday. Right? Everybody's got a different. If we're relying on people to tell us when something started or stopped, generally we're going to get incomplete information. How about this one? Do you hear that in the war room? All right, stop what you're doing. We got to give management an update. But we're in the middle of this. No, they need an update. Okay. We stop what we're doing. We go give management an update. It's funny how many smiles I got with that one. I like that. So it's not just me. Who owns the fix? Or other words, who do we blame? Right? Whose problem is this, and when will they get it fixed? And of course, this last one, since we're network people, we don't hear this a lot on occasion, right? All right. Do you see these aspects when you're in the war room often? It's like, oh my God, what the heck's going on in here? Everybody's running around like crazy. Can I trust that the guy who says, I'm all green here, I don't even know what he's looking at, and he says he's all green? Is he looking at the right area? Who knows, right? And this is the worst part. Although I have to admit I haven't had to do unscheduled overtime in quite a while. Gladly. But I used to do a lot of it. But it's not just the war room. So remember, the question is, why do we need visibility? It's not just the war room. It's also in the CIO staff meeting. How many people have been in a CIO staff meeting? It's a very different discussion up there, especially if there's not like the sky is falling. If the sky is falling, then it's like the war room. But if things are calm, the questions are different. Are we meeting our SLAs? Are our users happy? Right? Are we measurably contributing to company success? Now, this is a really complicated question and complicated answer. What has it got to do with the network team? Right? Well, the reason we're talking about it is it's all because of the visibility picture. If I don't have the right visibility, I can't tell you whether or not IT is delivering correctly to the business. And am I delivering cost effectively? Am I using the cheapest bandwidth possible with the greatest effect, for example? Are we investing in the right areas, and how would we even know? So if you've probably heard the statement, if you can't measure it, you can't manage it. You guys heard that before?
Yes.
Right? I mean, it's one of those universal truths. You can guess, am I on track? Am I meeting targets? Are customers happy? Well, I'll tell you if they're happy or they're not happy. But if you don't have objective data to back it up, you're not in a really good position. And then lastly, there's a lot of big plans dreamed up in the C-suite. Big plans, like cloud first. How many have a cloud first strategy or have heard that term, cloud first?
Yeah.
Right? Everything's going to the cloud. Okay, great idea. How are we going to monitor it? Oh, we'll worry about that later. It's nice and cheap, right? What's the impact if we decide to, like Marriott did? I use Marriott a lot, hotels, right? They came out with their mobile app. What's the impact if we get off of the web and do all customer interaction on our mobile phones? It's a pretty big impact. Got to rewrite all the code. Got new ways of interacting with customers. Big impact. So what's the impact if? Lots of impact assessment. But the net of it is we're going to spend money for some reason. How do we know if we're spending it wisely, if we're getting the value that we expect to get? And how do we know if we're supporting the business? So what's the solution to the war room issue, the CIO issue, the complexity of the hybrid enterprise? It is a complicated challenge. So I'm going to just give you part of it, the part that relates, I think to us. The solution is around developing solid requirements about what we need and why we need them in order to support the business. As long as we're holding up the idea that we're supporting the business and we can show the intent and the action that we're supporting the business, there's a good chance we're going to get the funding that we need to get the packets that we need and the visibility that we need. But why would we even want to go down that route? Because we've got to get the funding that we need. Now, the good news is Wireshark is free, and I love that. But I got to get the packets from somewhere, right? And I got to get them not a day after the problem occurred. I really need them before the problem occurred and after we resolved it, so we know exactly when it started and exactly when we fixed it, and that we can learn from it. So how you guys can help. And it's not going to be by showing management Wireshark display filters. As much fun as that is. Or there were some really cool scripts in here in the previous session that were fantastic. Make sure, if you weren't in the earlier session this morning, make sure you get the recording for that. So how you can help. You're going to assess your current packet capture capabilities, and you're going to identify gaps. And in those gaps is a business risk. Because where you don't have visibility, you can't provide support, you can't provide insight, you're behind the curve. You're going to translate those gaps into risk, and you're going to help management understand the risk and provide a roadmap to remediate. And part of what we'll do in this session is an exercise around what might that roadmap look like? And how can we simplify it and yet still make it effective? All right, so those two segments, the hybrid enterprise, the deployment, the why, that's all leading up to now the details around packet capture and packet workflow technologies. So thanks everybody for staying awake for those first two sessions. I do appreciate it. We're going to drill down now a little bit deeper into the packet arena. Okay. So it all comes down to defining requirements. We talked about building business cases, understanding gaps, doing an assessment, understanding business risk. These are all kind of collectively requirements of what we need to be effective to help the business. So let's look at some packet workflows and related technologies. So the first is I got to capture the traffic. I think we all agree with that. We're going to dive into that topic. We need to be doing monitoring. We're going to dive into that a little bit. We have to be able to do triage and troubleshooting. And we'll dive into some examples of what that looks like. Ideally, we should be doing pre-release performance analysis before some new application or new service goes into production, ideally. Right? Wouldn't it be great to identify bad code, bad protocol usage, bad design of the application before we go into production? How cool would that be? Would everybody like that? And then planning related workflows. That's the impact assessment, the what if, capacity planning, new location planning, new technology planning. How could we predict what will happen if, fill in the blank? If management decides cloud first, how do we know that we're still delivering good service to our customers? Okay. So we're going to start by deep diving into packet capture, into capturing packets. And there's a couple different ways to do this. I think some of this will be review for most of you in the room, but I wanted to make sure I covered it. So it starts with host-based capturing. And of course, you know, with Wireshark, you can turn on a capture if you've installed PCAP as part of the install bundle, right? Then there's network devices that capture packets. Some of them are simple, just record packets, write them to disk. That's all they do, right? Like a VCR. Yes, sir? Thank you. I think this is about where I'm supposed to be, I think. Network devices with capture capability, passive appliances, span and tap. We're going to drill into all of these a little bit more detail. So I want to give you an example of some host-based capture agents that you could deploy in the enterprise to literally every host. And what if you had such a capture agent? How would you talk to the agents, and what kinds of requirements would you like to see in terms of features and capabilities of those host-based capture agents? Well, the first would be able to see, well, which agents are up and running, and are they running a capture right now? That's what we have on this screen. And when did we start the capture? Who started it? Are there any filters that are in play, any capture filters that are in play. And then before we download packets from that agent, ideally we'd like to laser focus our attention on what packets should we care about. So how about if I could preview what's in the capture buffer before I actually go to the trouble of downloading and transferring packets across the network to get back to me so I can put them in my analysis tool. So ideally you'd have some sort of a preview that shows you what hosts have I seen, who are they talking to, and what kind of throughput has been generated by those hosts. So then ideally you could filter down into just the packets of interest and just the time period of interest. So host-based captures and some really important capabilities. So if you were to decide that, hey, I'm really only interested in traffic between these two hosts, which represents this spike of throughput during this period of time, notice down here, I could say, well, I just want to download what I've selected, which is 41 meg. Is that right? Yeah, 47, something like that. Versus 1.5 gig. So having some sort of way to preview and filter before you download is hugely valuable. So when you're thinking about host-based captures, these are some of the features that are really useful. So let's move on to passive appliances. So they're always on, they're always capturing packets based on what you're presenting to them. They can't capture packets you don't provide to them. So you have to marry these with a span and tap strategy that's going to make sure you're getting the packets that are of most importance to you. And we're going to look in a few slides down the road, we're going to look at ways of identifying what is the most important, what is the most valuable to our mission. Packet slicing and filtering, previewing before you actually download packets is another important feature. Here's a screenshot from one of Riverbed's, just giving you a sense of, from a I've captured packets perspective, okay, I've got 23 terabytes, I've got 4 days and 2 hours worth of packets in my buffer, just raw recording, and I'm capturing on one of my two interfaces, and here's some statistics about throughput and whatnot. These are not performance statistics, these are just how much data do I have? How many packets do I have in my buffer for what time period? So let's move on to span and tap. How many people here have designed a span and tap strategy? We got 1, 2, 3, 4. Nope, we got an itch. 4. So the main thing about spanning and tapping is it's not really a trivial exercise. It's trivial to turn it on. But it really is an engineering exercise. Deciding what am I going to span, what am I going to tap, where am I going to send it, how do I make sure that I don't oversubscribe the span. So some of the challenges are impacts to existing traffic. Hopefully, if it's done right, there is no impact to existing traffic. But I have seen cases where you turn span on and it crashed the switch. Not what was expected, right? Full duplex over half duplex and oversubscription are some challenges. And for tap design, same issue, full duplex over half, and then managed versus unmanaged taps. There are some taps that are very basic. I think it's okay to call them dumb taps, meaning they don't have any management. The good news is if there's nothing to fail, it's passed through, it'll generate the traffic if it's there. But there's some design challenges around tap as well. And then virtual taps for the virtual environment. Someone mentioned virtual earlier. Packet aggregators. So who's got packet aggregators in the environment? We got 1, 2. So gigamons? Say it again? Arista. So we call that on the other side Arista. Yeah. And then how about for you in the back? Appcon, yeah? Okay. Yeah, internally we've got some Ixia, we've got some Gigamon. All of those vendors do a great job. They've all got great features. It's important to drill down into those features when you're talking with them. Make sure there's filtering, aggregating, splitting, header and layer modifications, like being able to remove VLAN tags, insert VLAN tags, things like that. Timestamps, deduplication. Some actually generate flow data, which can be very useful for your flow collection tool. Some are single units that you can't really grow, and others are a architecture that allows you to scale at tremendous levels. Any questions, comments so far?
What's your take on the aggregators and how they do deduplication? So if they're picking it up from half dozen places on the network,
Yeah.
what's your take on their deduplication capabilities that aren't going to throw you off because you have to choose a MAC address from somewhere?
Yes.
So what's your
Yeah.
feelings on that?
Yeah, so my take on it is I was involved with them in the early days of deduplication on various vendors. It didn't exactly work the way they thought it would work. The challenge is huge, engineering challenge, because if you think about what an aggregator, prime mission of an aggregator is a packet comes in and it goes out as quickly as possible. That's the mission. Now you add deduplication, now I have to buffer, because I got to figure out, is this packet related to that packet? And now that I'm buffering, the game changes completely. I need more memory, I need more CPU, I need more ability to do error recovery. I think it's gotten better, but I've still seen instances where when dedupe is on, we're missing packets to our appliance. You know, they just don't show up. And it's a really hard problem to solve with the vendor. Because it's like, oh no, it must be your cables, or it must be your capture appliance, you know. But, all right. Monitoring passive appliances, always on, always analyzing application and network performance. And here's what's really interesting. It's all conversations that you feed it all the time based on the traffic that you're presenting. So imagine, you know, in Wireshark, I have a capture. I'm looking at a point in time. There might be 50 to 100 to 1,000 connections in there that I'm looking at, analyzing. The appliances that do this type of analysis are doing millions of connections concurrently. Every packet comes in, calculate new statistics, always on, always monitoring all conversations. The ability to do transaction level monitoring, like not only from a layer 2 perspective or a layer 3 perspective, but also what about web performance? What about web page performance? Can my analysis tool tell me about web pages, which are an aggregate of multiple connections and multiple objects making up the response time for a single web page? So having some ability to do transaction level monitoring is really important, as well as TCP level alerting and baselining. The idea is you want to use these appliances to help you quickly determine the domain of a problem. Is it the network? Is it the application? Is it the server? Is it the application code? Is it something else, somebody else's network causing the issue? If you can solve an issue without having to download packets, does that sound like a win? Man, I mean, as much as I love to look at packets, if I don't have to look at packets and can still solve a problem, I'm a happy camper. So let's move on to triage and troubleshooting workflows. So when you get into this type of activity, it's incredibly important to be able to filter and isolate the traffic of interest, right? When we've done some troubleshooting where people give us a PCAP. I mean, I've done it. I think other people in the room have probably done it. They give you a PCAP, you go, what's in here? Oh, it's the XYZ system from 1 to 2 o'clock yesterday. And you look at it and you find out it's not at all what they told you, what they thought it was. And now you go back and you get another capture and you find out it was pre-filtered or not pre-filtered. And anyway, just getting to the right capture can take a lot of effort. But being able to take a large capture of everything and then filter it down and isolate it to just the transactions of interest is incredibly important. And then having some sort of analytics that you can apply to your capture file to help you in the analysis is incredibly helpful. Overlaying traffic with key performance statistics. We're going to have an example of that coming up. End-to-end transaction views from multiple capture points. Yesterday in the TCP SAC session, we had two captures, one from a client, one from a server, merged together to help better understand which side of the connection did the problem really happen in, or was it in the middle? So we're going to take a quick look at an example of how we went from identifying an issue using a passive appliance and then quickly drilling down using into the packets of interest, quickly drilling down and using advanced analytics to isolate the root cause. So a little bit of background on, and by the way, we're about 4 minutes behind, so we're in good shape. I'm going to speed things up a little bit, see if I can do that, talk a little bit faster. So this was an issue with cloud database replication. This was a cloud-first customer that put its databases in the cloud somewhere in the on-prem data center, and they have to replicate between the various databases. And it's a full mesh replication between Amazon East and West, as well as two data centers. And it looks a little bit like this. So when I say, for this audience, when I say Amazon East and West, what I'm referring to is there's an Amazon data center in the northwest of the US, and there's one in the mid-Atlantic on the East Coast, generally referred to as AWS East and West. I think there's others in Europe. I imagine there's some in Asia Pacific for Amazon. Yeah. What do they call those? What names do they give them for the Pacific?
AP East.
Say it again.
So they have AWS have data centers in Singapore,
Singapore and Sydney. Okay.
Dubai also in India.
And in India. Okay. So this is US, West, and East, and then the two customer data centers, one in the Midwest of the country, one in the Northwest, and the arrows represent the replication flow between these databases. We happen to have passive appliances in the two data centers that can see all the ingress and egress traffic at the edge of the network. The problem reported was this replication here. We weren't getting reports of any other replication, and we didn't have any visibility to the east-west replication because it's in the cloud. These charts represent, there's actually, in each of those locations, there's 3 different database instances. So you're seeing 1, 2, 3 charts, one for each instance. Sorry for the redaction. I know it's kind of ugly, but that's the only way I could include it in the presentation. The blue lines represent throughput for each database instance over time. I think we're looking at a 3-hour window. And notice the blue lines have a very regular pattern and very regular behavior, peaking out at around, I'm going to call that 16 meg for this database, 14 meg, 13 meg. But it's consistent, it's repeatable. It gives you an opportunity to answer the question, what does normal look like? And that question is one of the most important questions you can ask when you're troubleshooting, because you got to know there's no way to know what not normal looks like until you know what normal looks like. Does everybody agree with that? So having baselines is super helpful. The red lines are the trouble connections, where you can see they never really get to the same potential throughput. Something is holding it back. What is holding it back? So I downloaded a 1-minute packet sample from the appliance that had the packets in the Northwest appliance, and ran it through some analytics just to see at a very high level what's causing the delay. And this particular view shows that about 75% of the delay is tier processing time in Amazon, and the rest of it is protocol delay. Now, I can't do anything about this because it's in Amazon, but I might be able to do something about that. So we're going to drill into the delay portion related to protocol. Some high-level statistics. Zooming into that previous screen, not really a lot of retransmission. So this is all internet traffic, so that's kind of interesting, right? No real retransmissions. Or is that a false positive? Could there have been retransmissions, we just didn't see them? So I'll answer that. There were triple duplicate ACK loss indicators. Remember, we're on the receiving side where our appliance is. We don't have anything on the sending side. So if there was packet loss, we really wouldn't know. We wouldn't see the same packet twice. So we can't really detect retransmissions, but we can detect triple duplicate ACKs, and we can detect out-of-sequence packets. So these are some high-level statistics. Earlier I mentioned one of the requirements you want to think about is being able to overlay statistics on top of traffic, performance statistics on top of the traffic. So here we've got throughput, we've got bytes in flight. And can somebody give me a definition of bytes in flight from the Wireshark perspective?
Hasn't received.
Say it again.
Hasn't received, but it's in flight, the data.
Right, so it's been sent, but not yet acknowledged.
Okay. Yeah.
Right? And I say that because sometimes the ACKs get lost, so the sender doesn't know. But yes, you're right. So it's in flight, has not been acknowledged. And then a graph around out of sequence. So now we've got some time series charts that we could overlay with the traffic. And this particular visual was extremely helpful because in that 1 minute sample where we thought we're seeing a continuous burst of traffic, it's not really that way once you get it down to the packet level. What we really have is we have multiple microbursts. So each of these bars is a histogram representing traffic being transmitted over time. And this chart is it's a time series chart of the in-flight data. How much data was in flight for each one of those bursts over a given period of time. So a couple surprises about the choppiness of the transmissions. So when on the appliance, it looked like continuous traffic, but really it's short duration bursts. We see in the 1 minute, again, we took 1 minute at random, right? Remember earlier I was saying filter, filter, filter. It's important to filter down. 1 minute packet capture, and then we zoomed in. We're going to zoom into a 400 millisecond burst just to see what it looks like from a statistic overlay perspective. So let's drill down. I picked that one at random. And now when we drill down into that, we can see the individual packets in the burst, and we can see how bytes in flight is changing over time. And who can tell me what that pattern is? Bytes in flight when it looks like that. Starts small, gets a little bigger, gets a little bigger, gets even bigger, and it keeps growing until something. So slow start, TCP slow start. Okay. So we did a deep dive. So this is an example of advanced analytics and how quickly you can come to some conclusions about why are things slow. We had the pie chart showing us who's responsible for delay, server, protocol. We did a drill down into a 1 minute period, and then we drilled down into a smaller period, 400 milliseconds. So it looks like slow start is playing a role. And here's the part at the very bottom that was a surprise for me. So I showed the DBA, who's not a network person, the chart, and I explained what in-flight meant. And he looked at it and he goes, oh, it wasn't the DBA, it was the Linux person. So we're in the war room. There's a bunch of network people, it's typical, right? Database, network, server people, help desk people. So the Linux guy says, wow, it looks like slow start on idle is the default for these servers. To which I said, what the heck is slow start on idle? I never heard of that before. I mean, you always find new things that, surprise you. At least I do. So what is slow start on idle? Anybody heard of that? No? So I Googled it, and it says that, all right, it's something new, that in addition to dealing with, usually slow start is a side effect of congestion, a saturated network. But no, that wasn't good enough. Somebody decided we need a new style that deals with the connection being idle for a defined period of time. So that was kind of a new thing for me. But the purpose of showing you that sequence of slides really was around, we were talking about passive capture, detailed analytics, spans and taps, getting all the data you need. We didn't have quite everything I would have liked to have. I didn't know what was happening at Amazon. I don't have instrumentation there. But I did have instrumentation at the data center side. So we could see that, yes, it is slow. That, by the way, the DBA was complaining that the replication was falling behind, something that they called lag. They said the data center is lagging Amazon. Something's wrong. The network is the issue. Why wouldn't you think that, right? There's a network in the middle. It must be the network. So the good news is we sorted it out. It wasn't the network. It was actually this slow start on idle. The Linux admin logged into the Amazon servers during a change window. I'll back up. He first opened a change ticket, got approval for the change, and then he made the change and significantly improved performance. Any questions, comments about, so we looked at an example of passive appliances drilling down into detailed analytical tools, and we were able to do that. I'm not averse to looking at decodes, but if I don't have to, I'm a happier person, right? So just by using pictures, we were able to identify the issue. Any questions, comments?
Just that sounds like to me they didn't configure the same configuration across the servers, the same settings, otherwise it would have had the same results.
Exactly. Now, latency played a part as well,
Okay.
because Amazon West is really close to the Northwest data center, really close.
Right.
So there's less time involved in dealing with slow
So
start.
it's not really, it's not identical then.
Yeah, because of the difference in topology. Yeah. So a key point I wanted to mention, the analysis, once we got the right captures, the analysis really was pretty quick. Put in the tool, generate the chart, show it to the Linux Bing slow start. What was painful was trying to find out what was the application architecture. What are the IP addresses? What are the tunnel endpoints? Because there's VPN tunnels between Amazon and the customer. What should we expect to see? Like we were showing bursts every 30 minutes. The DBA goes, why is it doing that? I don't know, dude. It's your database. It's every 30 minutes. This is what's happening. So he went off to research that. This is where most of the pain happens. Now this was a troubleshooting activity that came. We were lucky in that we had an appliance, but we didn't, and we were capturing all the packets, but we didn't have any context for this replication application. Is it 10 after?
Yes.
Okay. This is one of the toughest problems to solve. How do you get information about the applications that you're trying to troubleshoot? And if you can get them in advance and configure dashboards and configure containers for the traffic, then you don't have to wait for the DBA to call and say there's an issue. You'll already know it because you will have set up alerts for it. Okay, I'm going to skip through a couple of things because it's time to talk about money. Who here loves to talk about money? I actually hate to talk about money. In John's world, everything would be free, just because it's so much easier. Free is so much easier. But we do need to talk about money. And the reason is because in the business world, we can't get what we need unless we spend money. We can't get the resources we need, the people, the technology, the tooling, the facilities, the desks, the chairs, the outlets in the wall. So we know that packets are essential, but the challenge is the people who have the money, they don't understand why that's important. To them, it's like, oh, you want to buy a new shiny object, right? But that's really not the case. You're trying to solve business issues. They need your help to understand how the visibility gaps, and this is important, are actually a risk to the business.
It's usually after the case, after the fact, then they find the value in these kind of systems.
If you can solve the issue, yeah.
Yeah.
Yeah, exactly. But why can't we be preemptive? Why can't we prepare? Like, usually when the network team is designing a really great network, it's built for everything, right? It's a multi-purpose shared everything network, all applications. So the network team oftentimes will say, well, I don't really know what's on the network because I don't need to know. I built it to be super network. It can handle anything. Until the application teams get a hold of it, and then they start to abuse it in ways that nobody could have ever predicted, right? So they need your help. So how can you help? You're going to assess your capabilities. You're going to identify gaps and risks. You're going to translate those gaps into risk. You're going to help management understand. These are the general 5 categories of any type of business impact. Anything, any outage, slowdown, generally is going to impact the business in one of these ways, right? Lost revenue, lost productivity, penalties and fines. Anybody deal in that world where there's a fine because something was slow or late? Missed market opportunities, customer churn. Man, customer churn sucks. It's so hard to get customers that when they leave you, getting them back is painful, or replacing them is super painful. So I'm not going to have time to go through all of these, but these are some examples of troubleshooting activities where we were called in to help a customer because they were having impacts to the business and they couldn't solve the issue. And these were real events, very painful. I could talk for hours about each one of these. I'd love to. So tonight at dinner, if you guys are still here, if you want to talk, let me know. I'd be happy to talk about them. And now I want to get to identifying your key apps. So when you're trying to tie gaps back to the business, you have to do it in a way that the business can relate to, which is generally going to be an application or a service that IT is delivering to the business stakeholders. So you've got to be able to articulate your need in terms of those types of applications or infrastructure services. And one of the ways you can do that, and this is not complicated, here's an example of a spreadsheet where we're going to basically inventory a couple of the high impact business applications. Some attributes about the name, the technology, who's the business unit, how's it used, where's it hosted, how many people are registered users, and what's the peak user count. Now, what you'll find is nobody knows the answers to these questions. But the fact that you're asking starts to raise the antenna that, hey, these are actually important questions to ask, and we really should be able to answer them because we're making business decisions blind if we don't have this information. An estimate of how many outages in the last 90 days that were service impacting, and how many total minutes of those outages. And then you could start to estimate a cost, which is always a little dicey, but you can go low, medium, and high. If we had to guess, what would a low estimate be? If you had to guess, what would medium, what would high look like? Some dimensioning of what's the cost to the business if one of these key applications fails. And then the types of business impact, lost revenue, higher costs. You could actually put anything in these columns, But this gives you an idea when you're talking to management about why these things are important. Why these apps and not other apps. So it's hard to get these details, but these are the folks you could talk to. And then what you're going to do is you're going to, for each of the apps, you're going to create a heat map showing where are my gaps, where am I blind, and where do I have visibility. And we'll look at how we're going to do that. So we're going to do conditional formatting. We're going to visualize where you have coverage. So if we were to take our hybrid model just as a network design, say, okay, I need instrumentation here. I'd love to be, so I can see what the user's experiencing. I'd love to know when the web talks to the app, what the response time is. By the way, I discovered unexpectedly the web does actually talk to the database. Who would have guessed? So I better be monitoring that too. App to database, and then app out to my partner. So some picture that shows the architecture at a very high level. Not the details, but a super high level. And then we have the ability to take that information and map it in this heat map. So if you'll notice, we've got some views of performance views of end user experience. Can I see it for Oracle? Can I see it for TIBCO? Can I see it for PowerStrip? These are some internal Riverbed names. How about my web to app performance? Can I see it? Is it visible? Do I have access to it? How about app to database, app to partner, app to my single sign-on? Single sign-on is kind of important. So you're going to go through an exercise of assigning what level of visibility do you have? Do you have complete? I got everything I need in that intersection. Or, well, it's not complete, but I have some, so it's partial. And then a degree. So these two are super subjective, but they're important. Partial, light green, some risk, significant risk. Significant risk means I'm blind. I can't see anything. So if you were to fill this out for Oracle, and this is not reality, this is made up. This is a made up example. So the red says, I don't have what I need when end users are talking to Oracle. I don't know what the response time is. I don't know what the performance is. I've got no visibility into it. How about when the web talks to the app? Red, app to database, I got a little bit because I've got Oracle database tools, so I get a little bit of visibility. App to partner doesn't really apply, and single sign-on, I'm in trouble. So just with conditional formatting, you put a number in there and it changes the color. It's very simple. And then you do the same thing for the rest of the apps. And now you have a current state. This is the type of thing that management can get their head around. If you go in talking about supervisor cards and needing more memory on this box and things that are super low technical level, you'll lose them. But at a high level, this means something to a business manager. Once you can explain these, they certainly understand what these services are. So once you put that current state together, now you can put together a roadmap. What would I do first? What would I do second? And why? And you can articulate it, you can talk to it. So maybe this is phase one of our roadmap. We're choosing to say, you know what, I need to get full visibility to TIBCO. Anybody know what TIBCO is? Let me just say, TIBCO is a messaging enterprise system bus type of middleware. And chances are, like in our environment, everything uses TIBCO. All of our applications use TIBCO. So when TIBCO's down, bad things happen to everything. So TIBCO is pretty important. PowerStrip, so we're saying, okay, phase one, Mr. Manager, I think we need to address visibility for these two applications because they're so important to the business and there's so much risk. Phase two is I'm going to take care of Oracle, OBI, and ERP. I'm going to save finance for later. Now, this was a strategic mistake in my presentation. Who owns the money? Finance. We should have done finance first, right? So if you want to put that on the feedback form for this session, I'll update it for the next time I deliver this. And then phase three would be finance. So this is a simple way to communicate complicated concepts. When what you need is you need funding to fix gaps. Okay? this is one roadmap. It could have looked differently. Let's look at an alternate. So here was our baseline. Maybe the alternate is, you know what? Let's invest in end user experience for everything because it makes business sense. And now I've got visibility into how everything is performing. And at the same time, I'm going to take care of SSO because SSO is a critical infrastructure service. Anybody have SSO ever go down in your environment and you couldn't authenticate? Yeah, it's painful. So this is an alternate possible roadmap. So who owns the roadmap once you do the assessment? You guys do. You use your judgment, your gut feeling, your knowledge of the business to say, hey boss, I think SSO is the most important problem we have to solve, and here's why. And here's what it'll take to solve it. And then if I can get the visibility I need, I can be proactive, I can be preemptive, and should something hit the fan, I can react quickly and solve it quickly. Those are the values of fixing. What about key infrastructure and shared services? So now I'm not talking about an application, but key infrastructure, shared services. So what are some shared services that when they fail, bad things happen to the data center? Do these look complete? DNS? I mean, email, sort of. Email, oddly enough, in many environments, it's critical. If you're interacting with customers now over email, which a lot of companies are doing, if you don't reply back to a customer in a timely manner, you got problems. SharePoint, anything missing from up here that you would add to this list?
Proxy.
Say it again.
Proxy.
Proxy. So proxy servers, like a proxy farm. Yeah. So the VoIP would be like your SIP servers, your media gateways, things that, you know, VoIP just stops working if you don't have them. So you could think of these things as quote unquote key applications. You could use the same heat map to detail in what's my current state assessment of my visibility around the key infrastructure shared services. So you can see they're listed up at the top. And the columns changed a little bit because the idea of a web server talking to an app server doesn't mean anything for DNS. Right? Doesn't really mean anything. So what the views that we were using for an application don't really apply to shared services. So you could use some key metrics like, well, can I measure response time for DNS? That's pretty important to be able to do. Can I measure transaction rates? Can I measure connection rates? Maybe for DNS that doesn't really apply since it's UDP. Although there is some TCP for DNS. Can I measure resource utilization of the servers that support these different services? How about throughput rates? Can I look at packet loss and retransmissions? Do I even know it's happening? Do I know there's retransmissions happening? And then can I even get packet captures for these key facilities? So the rows really are customized to whatever makes the most sense for your mission. Make sense? Okay, want to see how hard this is? All right. Prepare to be overwhelmed. And I'll post this spreadsheet up wherever we post things, so you guys can utilize it if you like. So here's the key applications list, very simple. You could also do key sites as well. You know, maybe what you need to also focus on is, hey, if this site has problems, there's a big impact, let's make sure we've got the right visibility to this site. Branches for a bank, for example, right? And then here's the heat map. You just put in numbers. A 1 is dark green, a 2 is light green. So you just start to populate. Very easy, you can change it if somebody says, oh, wait a minute, that assessment doesn't make any sense, all right, fine. Then it's really easy to change. It's not complicated. And then I think we had something here for infrastructure services. So here's the infrastructure services heat map. Same kind of thing, conditional formatting. If you've never used conditional formatting in Excel, take 20 minutes to learn about it. It's super useful if you're trying to tell a story. Super useful. Does this look hard? I mean, the mechanics are easy. The hard part is doing the assessment, understanding what you've got, and trying to learn more about the business. Sometimes I do that. They go away. I don't have time to talk to you now. Oh, no, but this is important. Yeah, I know, but I'm busy. Go away. It's like, can we have lunch? How about dinner? How about a beer after work? Do you want to play golf on Saturday? I don't play golf, but people talk about golf. Golf is supposed to be magical. You take people golfing and you get all kinds of cooperation.
With the beer, awesome.
Yeah, there you go. Here's a view that's a little more comprehensive. And we're just about out of time. But these rows now represent kind of that complete picture that we saw in the early part of the presentation around full visibility. So being able to see end user experience, yes or no, application response time, network latency, can I see historical trends, do I have device configuration data? You can put anything that's relevant to you in the rows that you need to track, that you feel you need to track and measure and help management understand your gaps.
John?
Yes.
What would be the target audience of those types of questions, though? Because if you start firing those questions at the business unit, they're just going to turn around and say, what does that mean?
Right, so these particular rows would be what you as an infrastructure guy know I can get my hands on. So if there's, in the organization, if there's one group responsible for service level management or service level monitoring, you know, like a NOC or an application center that's doing monitoring, they would know what data they have available. And chances are, since you may at one point or another gone into a war room with them and bonded in natural ways, you could leverage that relationship to find out as well. Yeah. I think we did skip over just a couple slides, not many, and we are done. Any other questions or comments? Yes, sir.
So for the infrastructure services, basically we can handle because we have the tools like ping press or all the metrics. But how do you measure the end user experience?
So there's a couple different strategies for end user experience. So when we early in the presentation we saw endpoint device monitoring. That's the closest to the user and it will be the most accurate in terms of response time and application performance, okay, transaction performance. There was JavaScript injection for your SaaS applications as another method. Maybe you can't put endpoint monitoring agents, but JavaScript injection might be a good alternative. Third one was application agents on the servers that can measure application response time. The fourth one is network appliances that you put on the edge of the network that see all the ingress egress. And if those appliances can generate metrics around user response time, server response time, web page response time, those are additional ways you can get that information, right? The one that is the most accurate and most relevant to a user is what you're measuring on his device.
Then how do you have the packet capture strategy after that?
So if you have a passive appliance in the data center, it's going to be doing analytics and capture. So kind of the layered features are these appliances should always record packets, period. And then if they have additional functionality, it'll be what kind of analytics can you put on top of that. So you can always get to the packets and always see historical trends and do alerting on real-time alerting on performance. Same thing with the application-based agents monitoring the apps internally, the Java and .NET applications. And we can talk some more about that because we're just about out of time. General recommendations, in my opinion, leverage host-based captures everywhere you can, right? This is not a sales pitch, but if you see the Riverbed guys out in the table there, they can tell you about some options for fairly low-cost capture agents, where it's all you can eat. So put out thousands of agents. Use passive appliances to get coverage, response time, and user experience. Yeah. Add supplemental analysis capabilities on top of Wireshark. What Wireshark does, it does really, really well. But there's a higher level of analytics that would be extremely valuable. If you see them, you can decide, yeah, I could use them or not. I'll just stick with what I have. Either way. But advanced analytics are usually very helpful. And then the harder part of all of this, as we've been discussing, who do we talk to get this information, is identifying the key apps and where the inner tier, so web to app, app to database, app to SSO, single sign-on, which ones would be most beneficial, and then create a roadmap to expand your visibility to see those flows. Keep management informed. Like, I was working with a customer, and they invited me to their budgeting planning sessions and said, hey, John, tell us what we're going to need and why. And at least I had a seat at the table and could present, here's what I think, here's why I think it, here's an idea of the cost for budgeting purposes, and here's the benefit that you would get out of it. And it was so spot on to what they were trying to accomplish. Most of the times they said, yeah, we're gonna roll with this. So keep management informed, current state. Certainly every time there's an outage where you don't have visibility is an opportunity to say, geez, boss, if I had visibility that I said, that I've informed you about previously, we wouldn't have had such a long outage. It would have been quick. So I think we all agree packets are essential. We do all everyone has gaps. Nobody has all the money they would like to have. I should ask, does anybody have all the money they would like to have to get all the resources? No, it's always a trade-off. There's always a compromise. The key is to make sure that it's an informed trade-off and not a blind trade-off. And then create your future state roadmap. And thank you for participating today.